So I want you to title these notes Lesson 8.6, Notes 2. Lesson 8.6, Notes 2. And the only thing that we need to state about this one is what we're doing different that we didn't do in the first set of notes is when A does not equal 1, so when A does not equal 1, we can still try to factor, and I have to say try to factor. Of course, we're going to be able to right now, but we're going to learn that not all quadratic functions are factorable. Okay, I think we've already learned that before when we were just trying to factor quadratic, polynomials. So when A does not equal 1, we can still try to factor and set factors equal to 0 to get solutions. Or we'll just say solution. It could be more than one, but so in other words, when we're solving and A does not equal 1, we can still try to factor and then set our factors equal to 0 to get the solution. In other words, we set our factors equal to 0, use that zero product property that allows us to do that, get each factor solved for x, and then we know what our solutions are. So we're going to practice a couple of problems and then you're going to go to work. Now, today I am going to let you out of check problems, okay? Today you only have to solve them. These can get a little bit hairy trying to check them, so I'm going to not let you get frustrated with that part, but instead make sure that you are learning the solving process, okay? So we have this quadratic function, 3x squared minus 4x plus 1 equals 0. So we have to remember what we do when A does not equal 1 and we're using our diamond method. So let's first of all decide what our A, B, and C are in this one. So A equals 3, B equals -4, and C equals 1. If we did graph this, which direction would it open? Up, because why? Positive A value, okay. Can't tell me, there's one more thing you can tell me right now about this graph, right, without thinking very hard at all. What else can you tell me about this graph?
It's
going to be a fraction. How do you know? What's it's going to be a fraction? The solution?
When you substitute into the equation, it's going to be a fraction.
So the solution? Okay. Oh, so you're saying if we tried to find a vertex, you're convinced it would be, the x value would be a fraction, okay? Because of it's negative b over 2a, and you can look at it right now and say, you know what, I'm thinking that, okay? So you're working harder than I wanted you to, but good, you're right, it would have a fraction axis of symmetry. Okay, what else can you tell me without working very hard at all? Yeah, you're right, keep going. I just want you to finish it. The y-intercept is 1, yeah. Remember the c value is the y-intercept. So we would say, we know we have this parabola opening up. We right now know it's going to cross the y-axis at 1. And Noah added to it, he says, you know what, it's also going to have a fraction axis of symmetry. Okay? That one I wasn't necessarily looking for, but he was thinking harder than I intended for him to. Okay, so now let's go see how many times it would cross the x-axis. Okay, so what are we going to start with? First, when we're factoring with when A is not equal to 1, we're going to start with our diamond method. And so and remember we have to do what? Not just put C up here, but what do we have to do? We have to take A times the C. So we really need something that multiplies to be 3 and adds up to -4. Adds up to 3, or multiplies to be -3, or positive 3, adds up to -4. Okay, what are those numbers? -1, -3. Now, if A was equal to 1, we would say, I already know what the factors are. They'd be x minus 1, x minus 3. But A is not equal to 1, so we don't get to go to that step. What do these numbers do instead?
You put in the.
Cody?
You substitute them into the equation
For what?
for the negative 4x.
Yeah, they take the place of, so these actually become negative 1x and negative 3x is really what they become, remember? So now what we're going to do is we're going to rename our quadratic function as, instead of 3x squared minus 4x, it's going to be, let's change it to add the opposite, by the way, also, 3x squared plus negative 1x plus negative 3x plus 1 equals 0. So we've just now made it into a quadratic, no longer a trinomial, but now we have a quadratic 4-term polynomial. Now what do? Noah?
Yeah, you group them up, factor by group.
Yep, now we're going to factor them by grouping. So we're going to, let's put over here that we're going to factor by grouping. So when we look at our notes, we remember what was happening. We're going to factor by grouping. So in other words, 3x squared and that negative 1x are going to become their own group. The negative 3x plus the 1 is going to become another group. And if for a while you just want to ditch that equals 0, it's totally fine if we do. Okay? But all we're really doing here is we just keep renaming the equation. So what's the GCF of the first group? Negative x or x. Which one do you want it to be? Pardon?
1x.
1x. Okay, so just an x. So x is our GCF of this group, which means then after we factor out an x out of both of those terms, what do we have? Okay. Moving on to the other group. Remember, what's our goal in factoring by grouping?
To get our original equation.
Yeah, well, we're renaming our original equation, but don't we need, in the other group, don't we need a factor of 3x plus negative 1, right? Okay, so right now it's negative 3x plus 1. Is that the same thing?
No.
No. So what could we factor out of that so it would get renamed as 3x plus negative 1? Can we take an x out? No, there's an x in both terms. So we'll factor out a negative 1. And now negative 3x divided by negative 1 is 3x. 1 divided by negative 1 is negative 1. Now do we have matching factors? Okay, so we're just going to ditch that 0 for, it's okay if we do for now. What's our factor name now for this? No more plus signs between our parentheses. What's the name for this now? 3x minus 1 times x minus 1. Okay. So we've renamed it factored, no different than yesterday now, or the day before, I don't know how long we've been on this one. What do we do next? Use the zero product property, which says, no substituting really going on. We got pardoned? Well, if we foiled it, what should this do? If we actually foiled this, what should it take us back to? Its original name, but we're solving, remember? So what do we need to do with these factors? Set them each equal to 0 and solve for x. So the 3x minus 1 gets set equal to 0. The x minus 1 gets set equal to 0. So we should have two solutions according to this. So go ahead and get the solutions. Finish solving those little equations you have there. So we get x equals 1/3, do you agree with that? And x equals 1. Is this a fairly wide parabola or a fairly skinny, or you just, like kind of close to being the parent?
It's gonna be,
Okay, what's this parabola gonna do? It's like, okay, we've seen snow before, you guys, really, come on.
it's gonna open up, and it's gonna be skinnier.
It's gonna open up, remember, we already talked about that, but it's gonna be skinnier, why?
Because it's less than 1. Because the x is equal to less than 1.
You're kind of on the right track. What is, okay, if it's, so we're talking about wider, or, you're talking about transformations now, aren't you? Okay, but is that what these numbers are telling us? Are these telling us if it get wider or skinnier? It's the A value that tells us that. Are these the A value?
No, those are just what we substituted.
Yeah, these are the zeros, aren't they? These are the solutions.
These
So
are what
we-
get to get our points.
So we now know where it crosses the x-axis, right? The points where it's going to cross the x-axis. It's going to cross the x-axis at 1/3. It's going to cross the x-axis at 1. That's pretty skinny, isn't it? It's a pretty skinny parabola. Yeah. Okay, so all these things that we're finding, we got to make connections to what are we actually finding? What would this show us if we actually put this now on the graphing calculator and graphed it? It should cross the x-axis at positive 1/3, and it should cross the x-axis at positive 1. It should open up. Those are all things that we know. So we know that the solutions then now are solutions. Now, I'm starting to see some people do this. Write a parenthesis with 1/3, comma 1. We can't write it that way. Parentheses with a number, comma, another number is reserved for what? What's that called?
Coordinate.
And ordered pair, and they have 2 coordinates in it, and ordered pair, so we can't write it like that. If we want to write them together, we have to use what's called set notation like this. We would have to say 1/3, 1. The set of solutions. Or you could just write the solutions are x equals 1/3 and x equals 1. So don't be putting them in parentheses. I'm starting to see that happen. This is ordered pair 1/3, 0, and ordered pair 1, 0, not ordered pair 1/3, 1. Okay? Questions? Okay, we'll do one more. So we get to skip check problems today, I said, right? You don't want me to change my mind on that, right? Do you want to have to check 1/3? The 1 wouldn't be so bad, would it? But the 1/3 wouldn't be wouldn't be a great amount of fun. So why can't I get, okay. Number 2. So we're going to do one more. So you decide if you have enough room on the front of that sheet to do one more, or if you need to go to the back to do it. We're going to solve the following. Negative 9x squared equals 30x plus 25. Is this one ready to decide A, B, and C? We're going to get set equal to 0, don't we? Now, remember yesterday when we were having to rearrange them, I said, do everything you possibly can to get a positive 1 A value. Is it possible to get a positive 1 A value here? Positive 1
No.
A value? No. There's no way. If it was a negative x squared, yeah, but it's a negative 9x squared. So we kind of, we can't make the A be positive 1 no matter what we do here. Unless we want to start messing with dividing every piece by a negative 9 and renaming the equation and having fractions to deal with, and oh my goodness, life would just become way too complicated then. So my next suggestion is going to be, if you cannot make a positive 1 A value, at least make it a positive A value. At least make it a positive A value. So what could we do to make it so this will have a positive A value? Add 9x squared to both sides. Get that 9x squared moved over to the other side, because then it will be a positive A value. And just seems friendlier. What would come first here if we want to write it in standard form?
X squared.
The 9x squared, yep, and then followed by the 30x plus 25. Might as well just write it that way right away. Because addition allows us to put them in any order, right? Okay, now we can do our A, B, and C. A equals, B equals, C equals. Oof, we got some big numbers. 9, 30, 25. This is gonna be a good time. Gonna make our diamond. We're gonna take what times what?
8 times
9 times
25.
25. What is that?
225.
225. And then we have to get them to add up to 30. Now what did I say to you back? I had another hint for you back a while ago. I said whenever you have big numbers that you have to find factors of that have to add up to something else, what did I suggest you try first?
Square.
See if it's a perfect square. So go, is 225 a perfect square?
Yes.
Oh, it is. Nice. What is it? 15. Oh, does 15 plus 15 add up to 30?
Yes.
Love it.
Did you also have us like memorize those?
I did, didn't I? Did you actually do that? Good job. Okay, so now what are we going to do with those 15s?
Put them in my
They have to replace what? 30x, yeah. So we're going to rename 9x squared plus 30x as 9x squared plus 15x plus 15x plus 25. And remember, I said we can ditch the 0 for a while. Eventually it's going to come back and get set equal to each of the factors, so we'll just kind of ditch it for a while here. And now we're going to do what? Factor by grouping. Make our groups. Devontae, the factor, the GCF of the first group is?
3x.
Good job. The resulting factor is? Faith. Some of you I haven't heard from today. I want to make sure your voice is working. 3x plus 5. Thank you. Good. Abby, what is the GCF of the second group? 5. Good. And the resulting factor of that group is? Kelvin.
3x plus 5.
Okay. Do we have matching factors? Awesome. Okay, so our factored name for this is 3x plus 5. So that's this one. And then there's another 3x plus 5. I wonder how many solutions this one has. Only one, right? Because if the factors match, what would happen when you set the factors equal to 0? You get the same answer. It's the same answer. Can't cross the same place twice. You can't, on that place on the x-axis, you can't do that. There's only one point that, does not have a point symmetric to it, which, in other words, is the only one that is on there alone, and that's the vertex. So we're going to set this 3x plus 5 equal to 0 and solve it. Get our one solution. Is that a nice decimal? No. Should we give it its decimal name? No, not as nice. Can we name it as a mixed number? Absolutely, yeah. In fact, we want to know where this is crossing the x-axis, right? Tell me something about the graph for this one. Tell me something about the graph for this one.
Graph's vertex is on the x-axis.
The graph's vertex is on the x-axis. How do we know that, Cody?
Because if you only get one answer, your 0 is going to be your vertex.
Yeah. If we only get one answer, that means it's the x value of the vertex. The vertex is sitting on the x-axis. Depending on which way we rename this equation, we move the 9x squared over to the right side so it would be positive. If that's how we do it, then it's going to open up. And its vertex is still going to sit on the x-axis at -5/3. If we move the other stuff over with the 9x squared, we said, oh, you guys go over there and you be with the negative 9x squared, now our parabola would open down, which is okay, but where would its vertex be?
On the x-axis.
Still be on the x-axis at,
0.
no,
1 and over 1, negative 1 and 2/3.
negative 1 and 2/3, or negative 5/3, our solution we just got. So it doesn't matter, it still has the same solution. Just depends on which way you rearranged it, because we have to have it set equal to 0 to replace that 0 with a y to be able to graph it, right? So all of these things are, instead of just finding answers, I want you to put all this stuff together that you know. That's how you're going to remember it to take it into other math classes with you also. Not just for here to do your homework. But we need to retain this material so that next year as juniors, when you take that famous ACT test,
Yay.
you are not going to be sitting there like, I've never seen this before. Where did this come from? Because it's a whole year later. You'll be able to do it. Okay, let's go to work on homework.